Hello everyone, my project is research of spatial modulation based on space-time coding. So MAMO technology is widely used in modern communication. And spatial modulation is an important technique in MAMO. It could improve the efficiency of spectrum band and improve the rate of transmission. Space-time coding is also an important technology in wireless communication. Is a way for a system to attain signal coding diversity and higher data transfer rate. So as a result, we could combine the spatial modulation and space-time coding and apply it in cooperative communication system. So firstly, let me introduce the two-way relay system. The two-way relay system is a kind of the cooperative communication. So the working of the two-way relay system can be divided into two steps. So let's see the picture. The A and B are the sending nodes, and the R is the relay. Firstly, A and B send signals to relay R, and secondly, R just processes the signal from A and B in its own way, and then forward the signal into A and B. Since A and B knows its own information, the A and B can decode and get what another node wants to send me. And next, let me introduce two forwarding methods of relay. The first one is amplifying and forwarding, and the second one is decoding and forwarding. The amplifying and forwarding is a relatively simple way. By using AF, relay doesn't need to decode and demodulate the information from the sources, but just sends it directly after amplified. So as a result, relay cannot extract useful information from noise, and so the spatial modulation and space-time coding cannot be used in the system if the system apply the amplifying and forwarding method. So in my project, the amplifying and forwarding is not being used. The second one is decoding and forwarding. By decoding and forwarding, the relay will decode and demodulate the signal received from sources before sends it. So the relay could extract the information from noise, and as a result, the spatial modulation and space-time coding can be used. So let me introduce my first scheme, the relay SM scheme. In this scheme, the node A and B each have one antenna, and the relay has four antennas. The bit rate is 2 bits per slot, and the modulation is QPSK. In this scheme, firstly, A and B modulate its bits into QPSK symbols X and Y, and sends it to relay. And the relay just use the maximum likelihood decoding to decode what A and B sends to me and get the information. And then relay just combine the information into 2 bits. Next, relay choose an antenna based on the 2 bits just combined and send a certain power to A and B on the selected channel. In this system, the relay sends no signal to A and B, just a certain power in the signal, and A and B decode by channel decoding. So what is channel decoding? The channel decoding is that A and B decode to know what the channel the relay send the power to me, and and so the A and B can know what the relay want to send me, what information the relay want to send me. So this is the core of the spatial modulation. So next, let me let's see the performance of this system. So we can conclude from the figure that this system is not good because the slope is only 1. It indicates that this system cannot get the diversity. The bit error rate is very high, so it's not good. It needs to be improved. So my second scheme is LMTSM. So firstly, let me introduce LMT coding. We have two symbols, S1 and S2. The LMT coding just encodes the two symbols into this matrix. And so the system can get diversity by using different alterners. In this matrix, the, the rows indicates the different alterners, and the columns indicate the different time slots. By LMT coding, space-time channel is decoupled into two separate scalar channels. LMT code may attain diversity gain in the case with two transmitting alterners and a receiving alterner. So before I introduce my LMT SM scheme, let I introduce a simpler scheme which use multiple sender and a single receiver applying LMT coding. In this system, there are no relay, and the sending node has 3 alterners, receiving node has 1 alterner. The modulation is QPSK. So firstly, the sender modulates bits into symbols using two different constellations. The one is rotated, and the one is the rotated constellation of another one. And then the sending node just encode the information into symbols and sends it to the receiving node. So in this system, the information is divided into two parts. The first part is used to select a tenor, and the second part is encoded into symbols. When the receiving node receives the signal from the sending node, it just uses the maximum likelihood decoding to decodes and demodulates, and finally, the receiving node can extract the useful information from what it receives. In this system, the there are because there are only 3 alterners in the sending node, so the alterners is selected in a circular way to reduce the number of alterners. So that's the performance of this simple system. We can conclude from the figure that this system can get diversity. So since the LMT coding can make the system get diversity, why not we use it in the two-way relay system? So that's my second scheme, LMT SM scheme. In this scheme, the node A and B each has 1 alterner, and the relay has 3 alterners. The bit rate is 2 bits per slot, and A and B use QPSK. The relay uses BPSK. Firstly, node A and B transmit the QPSK symbol to relay R, and the relay receives the signal and decode and then demodulate get the information from A and B. Then relay just combine the information from A and B by XOR. So also the information is also divided into two parts. The first part is used to select a tenor, and the second part is encoded into symbols. So relay chooses a tenor, conducts BPSK modulation, and encode the second part of the information into alarm T symbols, and forward it to A and B. Finally, node A and B receive signals from the relay and decode. Since A and B knows its own information, it can know the information from another node by the decoding. The performance of the performance of this system is good. You can see the figure. The slope is 2, and which indicating that this system can get diversity. It's much better than the relay SM. So I just draw the two pictures I just draw the two performance result in one picture. You can see from the picture that the LMT SM scheme is much better than the relay SM. So the relay SM couldn't achieve high diversity, so that the SNR is low. So not the SNR, the bit error rate is low, and the quality of the whole system is bad. But the LMT SM applies constellation, rotating and selecting a tenor circularly, so the system can attain diversity and approaches full diversity. What's more, it uses less atteners, just 3 atteners, and has a low decoding complexity. So anyway, LMT SM is a good improvement of existing schemes. It's a good improvement of the relay SM schemes. So let's see my program. This is the MATLAB program, and it is run in a very long time. This is the result. So this is the relay SM, and this is the LMT SM. You can see from the figure that the LMT SM is much better than the relay SM. Okay, thank you. That's my project.